Hey team. Well, I did not anticipate doing this last lecture via video, but that's okay. You guys all have the handouts. All we have to do is section 5.4, dividing polynomials. And there's only two objectives in this section, dividing monomials and then performing long division of polynomials. All right, so here is the warm-up page, and you guys know the drill. Go ahead and pause this for a few minutes and take a shot at all of these, all of which you should be able to hopefully do. So go ahead and pause and try working on these, and then I'll come back with the answers. Okay, so on the first one, this would be a monomial divided by a monomial. And we just deal with each thing separately. Look at the numbers. 18 over negative 27. Okay, well, so first of all, we know the whole thing overall is going to be negative. And then we can reduce these numbers. We can take a factor of 9 out of both of them. So that leaves us with the 2 here. And then if I take a factor of 9 out of the 27, that leaves me with a 3. All right, so far I know I've got this much. All right. Then look at the A's. We've got 4 A's in the numerator. We've got 9 A's in the denominator. You can use the quotient rule, or just know that we're going to have 5 leftover A's in the denominator, or in other words, a to the 5th. And then the B's, we've got 8 of them in the numerator, 5 of them in the denominator. So we're going to end up with b cubed in the numerator. Okay, so that's it for that one. Okay, so the thing with this number 2, we're dividing a polynomial by a monomial, which means we have to take each term and divide it by what's in the denominator. So let's write it out. So in other words, we have to take 10x squared divided by negative 5x, and then we're adding 5x divided by negative 5x, and then we're subtracting 4 divided by negative 5x. So you got to be really careful with your signs on these. So if we go back to the first term here to simplify that, so first of all, it's going to be negative, and we've got 10 divided by negative 5. So that's going to give us negative 2, and then the x squared over x just leaves us with an x. Okay. All right, on to the next one. Well, again, this is going to be negative because we have this negative sign down here. And then we've just got 5x divided by 5x, which is just 1. All right, so minus 1. And then, well, this term is going to be negative because of the negative in the denominator. So we're doing minus a minus, so it's going to turn into a plus. And there's nothing else we can do to simplify that one. So we're just going to leave it. 4 over 5x. Okay. All right, I'm going to erase that stuff and scooch up. And there is a reason I was making you do long division here, because we're going to be doing this with polynomials, so this is kind of a good way just to jog your memory as far as how the heck do you do long division. So we start here. We want to say 45 goes into it how many times? It doesn't go into 3. It doesn't go into 35. So then we're looking at 355. How many times does 45 go into 355? Well, if you just do a little figuring on the side, it's 7. Okay, so then we take the 7 times 45. All right, so 7 times 45 is 315. And then we subtract that. Okay, so 355 minus 315 is 40. And then we bring down the next digit, which is 0. So this comes down, so now we have 400. So now we ask, okay, how many times does 45 go into 400? Well, again, do a little figuring, and it's 8. So we put the 8 up there, and then we multiply the 8 times the 45. 8 times 45 is 360. Again, subtract. 400 minus 360 is 40. And we bring down the last digit, which is a 5. And then we say, how many times does 45 go into 405? 9. And 9 times 45 is actually exactly 405. Okay, so 405 minus 405 obviously is 0, meaning that it divides out evenly, okay, with 0 remainder. Okay. All right, so we'll get back to that stuff when we start doing the long division. All right, I'm going to erase again and move on to the next page. So let's go back and look at dividing by a monomial in a little more detail. So we're dividing a monomial by a monomial. So in other words, a monomial over a monomial. I'm not going to write out the whole words because it's a little cumbersome with this chunky pencil. And a monomial is just a single term. So you could just think of this as doing a single term divided by a single term. Same thing. That's what a monomial means. Okay. And again, this is really nothing new. This is exactly the same stuff we did back in section 5.2 when we learned the quotient rule for exponents. So again, that quotient rule tells us that if you have a to the m divided by a to the n, all right, then you can combine those by writing a to the m minus n. Okay. All right, so let's look at some examples. 20x cubed divided by 5x. So of course we can just do the 20 divided by 5 is 4. Remember that a plain old x is the same as x to the 1. So then we've got 4 times x to the 3 minus 1, or 4x squared. Which you can probably intuitively tell just by looking at the exponents. You've got 3 x's on the top, 1 x on the bottom. That's going to leave you with 2 x's on the top. Okay. Another one, x to the 5th divided by 4x. Okay. So in this case, nothing's going to happen with the 4. We just need to combine the x's. So this is an x to the 1. So it's like x to the 5 minus 1, and then still divided by 4. So x to the 4th divided by 4. All right. If there's more than one variable, then just deal with each one. I'm going to erase this stuff and scooch up a little. All right, so we just deal with things one at a time. We've got negative 56 divided by 2. All right, so that's negative 28. We've got p to the 5th divided by p squared. So in other words, p to the 5 minus 2. And we've got q to the 7 minus 6. All right, so in other words, we've got negative 28 p cubed and q to the 1, and of course you don't normally write the 1, so we'll just write it as q. So negative 28 p cubed times q. All right, I'm going to move on to the next page. All right, so now we're looking at dividing a polynomial by a monomial. So a polynomial over a monomial, okay? And of course, a polynomial may have several terms in it. So in other words, now we're looking at something with several terms divided by something with just a single term. Again, I'm just going to abbreviate here, okay? And the technique that we use to do this comes directly from the technique for how we add fractions. So when we add fractions that have the same denominator, we are doing something over a denominator plus something else over the same denominator, and then we can just add the stuff together in the numerators. A plus b over that common denominator, okay? And for division, we are literally just going to reverse that rule. Okay, when we have some stuff added together, subtracted, could be more than 2 terms, but all divided by a common denominator, then we can just split it apart, okay, with each separate piece over that same denominator. Okay. All right, so just some important notes as we're doing this. The key thing is you have to divide every term in the numerator by the term in the denominator. That's the key. If needed, rewrite it with a division bar, like down here, a fraction bar. Okay. If they happen to write the problem, using this symbol, then just rewrite it like this. And be very careful about your signs between the terms, whether they are ultimately going to be positive or negative. All right, I'm going to erase this and scooch it up a little. Okay. All right, so let's look at this first one. And again, we're just going to split it apart into 3 pieces. Each piece is going to be divided by x. Okay, so we're going to have 50x to the 5th divided by x. And then careful, we've got a subtraction sign here. So then we're going to subtract 7x to the 4th divided by x. And then we're going to add x squared divided by x. Okay. And then we just need to go through and actually do all those divisions. So for this first one, we're going to end up with, I'm not going to keep writing these out every time. We're going to have 50x to the 4th. And then minus 7x cubed plus x squared divided by x will just be plain old x. Okay. All right, here's what I'm talking about. If it's written like this with the division symbol, we're just going to rewrite that over a fraction bar. I'm going to erase this and move up. So I'll just use this to rewrite it right here. So we're dividing this by negative 2 x squared y squared okay. So I've just rewritten the problem, so let me just get rid of this. Okay. All right, and it's just never a bad idea to just write the whole thing out. So let's start with the first term. So 2x to the 4 y to the 6 divided by negative 2. We got to be careful with that negative sign. X squared y squared. And then minus 3 x cubed y to the 4th divided by negative 2 x squared y squared. And then plus 6 x squared y cubed divided by negative 2 x squared y squared. All right, and then let's just go through and look at each one. All right, so this first one, it's going to be negative, and the coefficient is just going to be 1, because 2 divided by 2 is 1. All right, so we're going to have negative, and then the x's, x to the 4 minus 2, so it's going to be x squared, y to the 6 minus 2, so it's going to be y to the 4. All right, the next term, the term itself is negative because of this, but we're subtracting it. So minus a minus is going to turn into a plus. And it's 3 over 2, so we're just going to leave that. 3 halves. The x's, we've got 3 over 2, so we're going to end up with just an x. And 4 minus 2, we're going to end up with y squared. Okay. And then moving on to the last term. All right, we're adding it, but it's negative, so we're just going to subtract it. 6 divided by 2 is 3. X squared over x squared is just 1. Those cancel. And then y cubed over y squared is just y to the 1, or plain old y. All right, and that's all we can do. We can't combine any of those because none of those are like terms. So that would be the final form of the answer. All right, I tell you what, pause again, and then you guys take a look and work on the problems on the next page. I'll come back and I'll give you the answers, but I'm not going to work through each of them in detail. But basically, use the same techniques that I was just showing you. All right, so let me jot down the answers to these problems, and you can check your work. So for number 1, this should be negative 6 over x squared. All right. Number 2, let's see, that one would be x to the 6th. That's a 6. Divided by 6. Okay, number 3. This one will be 17d divided by c to the 5th. Number 4. All right, this one is negative 10 t to the 5th minus 6t cubed plus 3t and number 5 is 4ab squared plus 5b minus 2. All right, so check your answers and make sure if you had any errors, go back and figure out what happened there. All right, I'm going to erase that and go on to the next page. Where we will start to talk about dividing polynomials using long division. And again, here's where, again, we're going to get back to just numbers, dividing numbers with long division, because the polynomial technique is very similar. So in this case, we want to do 5612 divided by 2. So let's just write it, with the division box like this. Okay, and in this problem, 5612 is the dividend. D-I-V-I-D-E-N-D, I hope. The dividend is the number that is being divided. 2 is the divisor. D-I-V-I-S-O-R. That is the number we are dividing by. Okay? So we start, saying 2 goes into 5 how many times? 2 times. 2 times 2 is 4. Subtract. 5 minus 4 is 1. Bring down the next digit, which is 6. 2 goes into 16 how many times? 8. 8 times 2 is 16. Subtract. 16 minus 16 is 0. Bring down the next digit, 1. 2 goes into 1 how many times? 0. So then we just, we can go ahead and write the 0 here, and we end up with 1 minus 0 is 1. Bring down the last digit, which is 2. 2 goes into 12 how many times? 6. Okay? So, in this case, it divided out evenly, because when I do 6 times 2 is 12, and then 12 minus 12 is 0. All right? The number that's left is the remainder. In this case, the remainder is 0, which means it divided evenly. Okay? So the quotient, Q-U-O-T-I-E-N-T, is 2806. All right, that is the number on top of the division box. The result is the quotient, okay? And the remainder is 0. R-E-M-A-I-N-D-E-R. All right, the remainder is 0, and that is the number that we end up with down here at the bottom, okay? And we can check it by saying, doing the reverse problem, taking the quotient, 2806, times the divisor, which was 2, plus the remainder, which was 0, is equal to the dividend, what we started with, 5612. So you can kind of back calculate it that way, and yes, that does equal that, so that checks out. Okay? All right, so let's look at one that does not divide out evenly. So I'm going to erase all this and move down. All right, so another problem, 5612 divided by 3 in this case. Okay, so I'm not going to write all this out again. You can copy it from above. But in this case, 5612 is the dividend. 3 is the divisor. Okay, exactly the same as up above. So let's put it in the division box. So we're going to do 5612 divided by 3. All right, 3 goes into 5 how many times? 1 time. So 1 times 3 is 3. Subtract, we get 2. Bring down the next digit, which is 6. 3 goes into 26 how many times? 8. 8 times 3 is 24. Subtract, 26 minus 24 is 2. Bring down the next digit, which is 1. 3 goes into 21 how many times? 7. Multiply, 7 times 3 is 21. Subtract, 21 minus 21 is 0. Bring down the next digit, which is 2. 3 goes into 2 how many times? 0. Multiply, 0 times 3 is 0. 2 minus 0 is 2. Okay? So, in this case, we have a remainder. All right? So, again, I'm not going to write all the words out here. You can check above. But what we have is that the quotient is 1870. Okay, that is the quotient. And the remainder is 2. So again, the quotient is the number up here, and the remainder is the number that is left down here. So in this case, one way to write the answer, and this is the way we're going to write our answers with the polynomials, is we would write our answer as quotient plus remainder over divisor. Okay, which in this case would be, the quotient is 1870 plus the remainder is 2 over the divisor was 3. Okay, and then we could go back and check, does that work? If we take the quotient 1870 times the divisor, which was 3, and add the remainder, which was 2, do we get the dividend, which was 5612? And if you just double check that on your calculator, you will see yes, that is true. Okay? So this is exactly the same procedure we're going to do, except that we are going to do it with polynomials instead of just plain old numbers. All right, I'm going to erase this and move down. So before we start the first problem, here's just a couple of tips on long division. You always want to, just in case they're not already, you want to put the terms in descending order. Okay, descending order. So remember that means from highest degree to lowest degree. So you would start with your highest degree term, maybe an x to the 5th or an x to the 4th, and then you would go in order down to the lowest degree term, maybe a constant, just a number. If any of the terms in the polynomial are missing, you need to include a 0 as a placeholder. I will show you an example of exactly what I mean by that. If the polynomial divides out evenly, then the answer is just going to be the quotient. Okay, and again, the quotient will be the thing that is left on the top of the division box. If it does not divide out evenly, then write the answer as, okay, and I want you guys to write this here. I'm not going to write it out again because I just wrote it on the previous page. I'm just going to say it. My hand is cramping up. You write your answer as quotient plus remainder over divisor. Okay? So quotient plus remainder over divisor. It's exactly what I just wrote out on the previous page. All right, so I'm going to erase this and move down so that we can look at a first problem here. All right, so we want to do this polynomial divided by x plus 3. So first of all, this is already written in descending order, an x squared, an x, and then a constant. There's no missing terms, so we're just going to write it out using our division box. So we're going to write x squared plus x minus 6 and then add in our division box, and we are dividing by x plus 3. All right, now here's the thing. How do we decide what the first thing is we put up here? Okay, we do this. We look at the first term here, x squared, divided by the first term here, which is x. So in other words, we look and say, what is x squared divided by x? Okay, well, it's x, right? So therefore, x is the first thing that we put up here. Okay. And then, just like in arithmetic division, we need to take x times this whole expression. X times x plus 3. So in other words, first we do x times x, which is x squared. And then we do x times plus 3, which is plus 3x. And notice how my x squared terms are lined up, my x terms are lined up. All right, the next thing we do is we subtract. Okay, so we're going to subtract this whole thing. Okay, and this is the trickiest part. So I'm doing x squared minus x squared. Well, that's 0. And that's the whole point. The first terms should always subtract and give you 0. But then here's the thing. I'm doing x minus 3x. So 1x minus 3x is negative 2x. Okay? So that's the harder part to remember, is that you're also subtracting all subsequent terms, not just the first one. They're all being subtracted. X minus 3x is negative 2x. All right, then we bring down the next term, which is minus 6. And then we just start the process over again. Okay? We look at the first thing here, which is negative 2x, over the first thing here, which is x. So negative 2x over x is negative 2. So a negative 2 is the next thing that goes on top, minus 2. All right? So now I want to take that minus 2 and multiply it by this expression. Okay? So if we do minus 2 times x, well, that's minus 2x. And then if I do minus 2 times 3, that's minus 6. And then we subtract again. So negative 2 minus x minus the quantity, negative 2x minus 6. Okay? So minus 2x minus a minus 2x turns into a plus 2x. Negative 2x plus 2x becomes 0. Sorry. So like I said, minus 2x minus a minus 2x turns into a 0. Okay, you can put it there or just leave it blank. And again, that's the whole point, is that that will always be 0. And then we've got minus 6 minus a minus 6. Well, that turns into minus 6 plus 6, which is also 0. All right? So in other words, this one divided out evenly because the remainder is 0. Okay? So in this case, the answer is just this. That's the quotient, x minus 2. And there is no remainder, so we don't have to write it. Just doing this, x squared plus x minus 6 divided by x plus 3 equals x minus 2. Okay, let's look at one more on the next page. And I actually want to change this problem just a little bit. Okay, I want to change it to this. 2x to the 4th minus 5x squared minus 4 divided by quantity x minus 3. So we'll leave that alone. All right, so now when we look at this polynomial, here's what I want you to notice is that there are missing terms. There is no x cubed term, and there is no plain old x term. All right, so when we write out our division, we're going to include a placeholder for each of those terms. All right, this is a very important step. You've got to do this. So let's write the polynomial out. 2x to the 4th. And then, like I said, there's no x cubed term, so let's include a 0x cubed. That is my placeholder term, okay? And then we've got minus 5x squared and there is no x term, so again, a placeholder. So include a plus 0x and then minus 4. Okay. Put in our division box. And we are dividing by x minus 3. All right, we're going to start exactly the same way. Look at the first term here and the first term here. So 2x to the 4 divided by x. All right, so that is going to be 2x cubed. That is the first thing that goes on top. That's the first piece of the quotient, 2x cubed. Okay, take that, multiply by x minus 3. 2x cubed times x is 2x to the 4. Hold on, I want to switch back to red here. Two x to the 4. And 2x cubed times minus 3 is minus 6x cubed. Okay, you see why we needed to have this placeholder here? Because now I've got an x cubed column here. Otherwise, it's going to start to not make any sense. So now we're going to subtract this quantity. 2x to the 4th minus 2x to the 4th is 0. 0, or 0x cubed, minus a minus 6x cubed is going to be positive 6x cubed. All right, positive 6x cubed. Bring down the next term, minus 5x squared. Okay. All right, same as before. Look at the first thing here, which is 6x cubed. Divide it by the first thing here, which was x. Right, that's going to be 6x squared. So that will be the next thing that goes up here in the quotient line. So it's going to be plus 6x squared. And now we will take 6x squared times the quantity x minus 3. So the first one, 6x squared times x, is 6x cubed. Six x squared times minus 3 will be minus 18x squared. And subtract the quantity. Six x cubed minus 6x cubed is 0. This will always be 0. That's the whole point. And then we've got negative 5x squared. Don't forget the negative sign. Negative 5x squared minus a minus 18x squared. So this turns into plus 18x squared. So really you could think of it as 18x squared minus 5x squared is going to be 13x squared. Okay. And bring down the next term, which is a plus 0x. That's our placeholder. And start by looking at this first thing, 13x squared, over this first thing, which is x. So that's just going to be 13x. So that is the next thing that goes up here, plus 13x. And now we're going to take the 13x times x minus 3. So 13x times x is 13x squared. And 13x times minus 3 is going to be minus 39x. Okay. And we're subtracting this quantity. (13x squared minus 13x squared is 0. 0 minus a minus turns into a plus 39x. It's just going to be 39x. Okay. Bring down the next term, the last one, thank God, right? Which is minus 4. Okay. So take this, the 39x, first thing there, over the first thing here, which is x. All right, so that's just 39. All right, so that'll be the last thing that goes up here on the quotient row. It's going to be plus 39. Okay, now we got to take 39 times the quantity x minus 3. So the 39 times the x is 39x. 39 times minus 3 is minus 117. And now we're subtracting this quantity. 39x minus 39x is 0. Negative 4 minus a minus 117. So that actually turns into plus 117. So really it's 117 minus 4, which is going to be 113. And we are done because there's no more terms to bring down. So this did not divide out evenly, and our remainder is equal to 113. Okay. So to write our answer, remember we want to write quotient plus remainder over divisor. All right, so our quotient is all this stuff up here on top of the division box. So our quotient is 2x cubed plus 6x squared plus 13x plus 39. So that's the quotient. And then we have to write plus remainder, that's 113, over divisor. And that's the thing that we divided by. So 113 over x minus 3. Okay, so that's all the examples I had. So here's what I want you guys to do. I'm going to add in, I've actually got 2 pages of practice problems for you here just because I thought this is something that you probably need to practice a few times. So since we can't do it together in class, I want you to do it and then, you know, turn it in as a bonus homework assignment. And by bonus, I just mean I added one. So you've already got an assignment due this Sunday. So this would technically be due, I guess, next Sunday, March 22nd. But if I were you, just, you know, watch after you've already watched this video. Just start working on these right away and just turn it in as soon as you can. Okay? So let me just make a few comments about the problems. Number 1, you will find that there is no remainder. Number 2, you will find that there is no remainder. Number 3 has a remainder. And for the ones that do have a remainder, remember to write your answer accordingly. I want you to write quotient plus remainder over divisor. Number 4, you will notice that there are a couple of missing terms. All right, so make sure that you add placeholders in for both the z squared and the z terms because they're missing. This problem does not have a remainder. It divides out evenly. For number 5, there is a missing term, the b term, and there will be a remainder. All right? So go ahead and start working on those and just start sending me your answers and work, and I'll take a look at them and let you know if you need to fix anything. All right, see you later. Or I guess I won't. Talk to you later. Okay, bye.